Oh, nope. Okay. Oh, no. Oh. Nope. Sorry, 1 second. Technical difficulties. Oh, how do you swap? Oh. Okay. Okay, so hi, my name is Marco Lisanek. I graduated from Full Stack in 1801 cohort, so that was this past April. And now I'm actually working for a digital media hip hop startup in the city, so pretty fun. I'm going to talk to you guys about pass by reference, pass by value. Chris gave you a little bit of an intro based on what I'm going to be talking about right now. This is a very important concept, so just bear with me. I'll try to dumb it down for you so you guys understand everything that I'm saying, and just stop me if you have any questions at any time. So an overview, we're going to be looking at primitive data, primitive values versus complex values, what those actually are. We're going to be looking at the differences between assigning primitive values to variables versus assigning complex values to variables. And we're going to be looking at the difference of passing in primitive and complex values to functions and how the equality operator interacts with complex and primitive values. So, does anybody know an example of primitive values?
Numbers.
Yeah, cool. That's 2 of them. There's 6. Boolean, number, and you have null, then you have undefined, and then in ES6 you have symbols. I wouldn't worry about symbols for now, but just know that they exist. Then you have complex values, which are objects as well as arrays. Arrays are technically objects, but behave differently. And then you have functions. So, primitive behavior. Oh yeah, thank you. So, since numbers are primitive, we're going to set a variable, number 5, and I'm going to set it equal to 5, right? So, then I'm going to set another variable, number 10, and I'm going to set it equal to number 5. Then I'm going to say number 10 is equal to 5 plus number 10. So then, once I console log these two, what are the 2 values going to be? What's number 5 and what's number 10?
It's going to be, you're going to log out 5 and then you're going to log out 10.
Right, exactly. The numbers, so when you change number 10, even though you assigned it to number 5, the actual value doesn't change. Now when you look at complex behavior, so I'm going to be talking about arrays since they're kind of a little easier to deal with than objects are. So you set number 5 equal to an array with the integer 5 at index 0, right? And then you set number 10 equal to number 5. So now number 10 is equal to, I guess, an array at index with 5 at index 0. And then I'm going to say number 10, the value at index 0, I'm going to reassign it to 5 plus the value that's there, right? So once we console log these two, what do you think is going to happen? You just saw it with Chris. Are they going to be different? Or are they going to be the same? Right, they're going to be the same. So the reason for this, I will explain to you now. So let me hop over to is this big enough? Do you guys want me to make it a little bigger? Is that cool? Okay, cool. So, oh, nope, did not want to do that. All right. So let's say, so like I said before, like let 5 equal 5, let 10, no, whoops, let 10 equal 5, and then 10 equals 5 plus 5. So console.log 5 and 10. So I'm just reiterating that these are 2 different values. And there's a reason for this. This is because whenever you are assigning something to, like let's say, like see on line 3, how I'm assigning the variable 10 to another variable that is a primitive value. what's happening is actually 5 is basically a copy of the actual value. That's how primitive values are assigned. It's copying the actual value and throwing it into 10. So 10 and 5 are no longer related anymore. You can do whatever you want to the to 10, but 5 will always stay the same. So now, if I put this in an array, let 10 equal 5, and then 10 at 0 is equal to 5 plus, I'll do 10 at 0. Now you have two arrays that are exactly the same, because 5 has changed. Because when you're assigning something from a complex value, that means that, like Chris said before, you're passing a reference to that value inside of memory. It's a little different. So you can really think of references like, for like a real world example, well, not really, but like let's say I give you all pieces of paper with the address to my house. Those pieces of paper are a reference, but I have one house. There's one thing somewhere else. It's not here. But you guys know the address, so you could go there and do stuff and change that to the same thing, the house, but all of you are different variables, if that makes sense. Maybe you didn't, but think about it like that. So, right, so when you assign a primitive value to a variable, the variable stores a copy of that value, like we saw. And here, when you assign a complex value to a variable, the variable does not store a copy of that value. It doesn't store a copy, it stores the reference, which points to a place in memory, somewhere else, where the actual data is being stored, and no copy is being made. Right, instead of variables stored in reference in memory, the reference points to the value, and when you assign a variable to a complex value, the variable stores a reference to a place in memory where the actual value is stored. Everyone good on that? Yeah? Cool. So now let's look at how this would change if we pass it into a function. So I can do, first I'll say let my num, and I'll set it equal to 5. Okay, we got a variable equal to a primitive value of 5. Then I'll do, then I'll make a function called add 20, right? This will take a num as a parameter. I'll just call it num, and I will do, num plus equals 20. You guys are familiar with plus equals, right? It's shorthand for num equals to 20 plus num. And then we have, then I'll just return num. And then here, I will set another integer, so results, I'll call it, equals add 20, and then I'll pass in my num. So then here I'll console.log my num. Nope, not my bum. My num. And we'll do console.log results. So, oh, whoops, typo. So, I'm sorry, what? There's another one? Oh, sorry. So here, what do you think will be logged out on line 10? My num. What do you think my num is? Right, 5, right? And then what is result going to be? 25, right? Right, 5, 25. Since it's primitive, the value is actually, so you're taking my num and you're passing it into this function here. So this is the parameter of the function. The value that my num is being assigned to is actually being copied and put in here. So it's still here, it's fine, but the value is copied, no more connection, goes into the function, adds 20 to it, and it spits out the answer, 25. So that was primitive behavior. So let's check out complex behavior. So I'll set this equal to an array of 5, and I'll do this push 20. So then I'll do num.push 20. And then I'll return, no, well, I'll make this array instead. Return array. So result push. I'll change this to my array too. So my array. So now we have. So now we're going to console log my array and result. So what do you guys think is going to happen? Do you think the two values are going to be the same or different? The same, right? Right. Because assigning complex values and passing in complex values works in the same exact behavior. So instead of making a copy of this and putting it through there and cutting relationships like you would with the primitive value, this is complex. So what you're actually passing to this function is actually a reference. It's the same exact thing. You're passing the reference to this, which is stored in memory, like you saw on the board over there, stored in memory. So here, this is the reference to the actual array, and you're pushing pointing to the actual array, and you'll see that both those things are pointing to the same thing, which is why they're both logged out here. See, by the way, push knows to look for the reference. Push knows to do that by itself already. Okay.
So are they both equal?
Let's find out. Find out. So I will do. Yeah, because they're both pointing to the same exact thing. The value is exactly the same. There's no copies, no nothing. But like Chris said before, there's a way. So let's say like you don't want to change your data, right? So there's a way to make a copy, and that's by using the slice method. You could just slice it out. So you could just do like my array is equal to my array. Whoop, my array dot slice, and then will be false because slice automatically makes a copy array. A lot of array methods make copies of the existing array, like map, for example, also does that. I don't know if you guys have used map yet, but it's very important to make sure that you know what it is exactly is going to happen with your function when you're dealing with complex data types, because in the future, for some jobs, maybe you might be dealing with humongous amounts of data. And those data will, I guarantee you, always be objects or arrays, pretty much. So you just have to be careful, and this is a really important thing to know about. Just in case, you're writing like millions of functions and, something like this. I don't know, it could cause problems, so just be aware of it. Okay, so when primitive values are passed to functions, the value is copied, like I said. Everyone good on that? Understand. Primitive values copied, and then they're passed in. So the original variable will not have its value changed. And then the same thing, except completely different. When you pass a complex value to a function, the reference is passed, not the actual value, not the value. The reference is passed, so the original variable will be modified. You will be changing the original thing. Everyone good on that? Yeah? Okay. So now, once again, the equality operator with references and values. So triple equals will compare values by reference, not by value. So, like we saw in here, so these are not the same thing, right? So here, let me just get rid of all this to make it a little more clear. So like you say, let A equal A, right? And then you say let B equal A. So A is equal to B. Yeah, it is. Because it's looking at the value here. Because the values are copied and they're primitive. But if you change it to something complex, like these can even be the same thing. And then if you reassign it and you just say these could be the same thing, they're just empty arrays, right? So you would assume that they'd be equal to each other, but they're not, because you're making two different arrays in memory. And since you're just checking for reference, they're not referencing the same thing, since you're actually creating two separate empty arrays, right? But if you change this to A, now they are true, because once again, assigning this is complex. If you're assigning a complex thing to this, it's being assigned a reference. So the thing is still there in memory. So this will evaluate the true. Yeah. So recap on the lecture. That's pretty much all there is to it, really. So we have primitive versus complex. That's what we talked about. Which data values are primitive, which are complex. You have string, numbers, booleans, null, undefined, and symbols for primitive, and then you have objects and functions for complex. Variable assignment, the assignment differences between complex types and primitive types. When you're assigning primitive types, like, once again, you're making a copy of the actual value. When you're assigning complex types, you're assigning it to the reference. And pretty much the same type of logic goes into functions. When you're passing in a primitive type into a function, a copy of that value is passed into it. And then when you're passing in a complex data type, the reference is being passed into it. So so if you have two things referencing the same, two variables referencing the same thing, and you're passing one into the function, but the other one you're expecting to stay the same, it won't stay the same, but it will change if you're modifying it in your function. And the equality operator, compares by reference, not by value. So that's it. That's all I got. Any questions? Nothing? Okay. Okay. So you were saying like let high equal function So these are the same, right? You're going to do the same thing, right? Everyone agreement? But does hi equal hello? No, right? Right. Because functions, like arrays, are complex. So everything I was saying about all this stuff, the same can be said about functions and just plain old objects, not just arrays. I just wanted to focus on arrays because arrays are a little bit like easier to manipulate, and Anything else? Yeah. Wait, what do you mean?
If you're comparing one primitive with one complex.
If you're comparing like a number to a function?
Yeah, if you can compare the complex value and the primitive value, and using the equation, like the equal sign, would that evaluate to false?
Like if I'm saying like let A equal this and let B equal like this?
Yeah.
Right, well this will be false. I'll tell you that right now. Because, these are one's primitive, one's complex. And so this is a string and this is an array. So they're just like not the same at all. There's really no relation. But if I did this, then this would be true. Because now I'm not saying, hey, look at this array, is it the same thing as a string? I'm saying, hey, array is 0. B is, can you see it? Is it? Array B is 0 now. I'm looking into the array at the first index, at the 0th index, and that's a string. So this is a string, this is a string, and they're the same string. And it is important to use triple equals because, like that's true for some reason if you use double equals, because double equals doesn't really take into account the type. It just looks at like what the thing is. So this is a string with the character 1, and that's just the integer 1. And it's saying that these are equal, but they're not. So this could get messy if you're using double equals in your code. So I would really, really, really recommend you just always use triple equals. Anything else?
So if you uncomment the top one, and then you set at hello to high, array that function for low, and you just set it to high, it's going to be, and then you compare it, it's going to be true. It's going to that reference point at high, right?
Yes, sir. You got it. Yep. Functions, everything I said about arrays, functions are the same, just by reference. They're pointing to the same function in memory. Anyone else? I got a lot of time, so.
So before you use an example where, like you're at a job that has maybe thousands of users of information.
Millions, yeah.
How do you know that like it doesn't exist anywhere else?
What do you mean?
I'm trying to figure out how to verbalize what I'm thinking.
That's cool.
Give me a minute.
So Liz, you mean like there's not a separate copy of the same
Right, like
data
how?
set?
Yeah, it's like how do you? I don't know. I'm having a.
Like,
Let me see if I can work this out in my head.
so you have like a giant piece of data, right? And
Right.
it's, let's say it's an object, right? So what are you trying to say? And I'm like an employee, and I need to do what? I need to like find that, see if that object already exists.
Yes, but like, how would you know if there's no way to know whether if they're all separate pieces of information, except for data points? Say there's only there's two pieces of information, and all of this information, for whatever reason, is one. You need to find those two. How do you, if there's that much information, how do you find out if they're equal? Or is that something that's like
That's just like case in point.
Yeah,
Well, it's sort of related, but it's like case in point kind of thing. Like like maybe you'd have to write a function to find out. Yeah, pretty much just like parry through it. If it's an array, loop through it. If it's an object, just kind of look up what exactly you're looking for. Most things, most in real world, like most data is like objects within objects within objects. So it's constant lookup time all the time. Like Chris mentioned, objects are great because when you're writing algorithms, let's say for job interviews or just for your own projects, because you want your code to be fast, you want them to run as fast as possible. When you're looking up like a key in an object, that's constant run. It's constant. It's fast. It's instantaneous. So that's amazing. Like you said, arrays, you have to loop through the entire thing. Possibly, it'll be the first thing in the array. But possibly, if the array has a million indexes, you'll have to loop through it. Yeah, any more questions on this?
To answer the question a little bit more, you mentioned like in the example of the phone book, where it's some big application where you create a phone book that's going to have a million phone numbers inside of it. Then that's on the developer and the team to make sure that we only ever generate one phone book. And every other variable is going to be a reference to the same phone book. Which makes it that we have to be aware of where that came from and to use the same references rather than ever go generate a new phone book. And so it just comes down to best practices in the architecture of the program to make sure that everybody is using the same reference and nobody happens to just generate a new object that they work off of only in their one little file. So we share the reference among all of the different files and we're possibly going to use this phone book object. Then it would make more sense to make something like that a constant to be able to do something like that. Well, like if you made the constant variable phone book, it means that we just can never reassign that variable to be anything else. But that's not going to stop anybody from creating a new object and adding numbers to that new object. It's more so just that you learn on your team the structure of the architecture, and you'll use the correct data sources, like how to import that phone book, and make sure that your data the application is adding to the same one as everybody else. That's it.
Thanks, Chris. Okay, so I guess we're good. Thanks for listening to me. I hope you guys learned something. Thanks.